Right, welcome back everyone. So, you should by now have watched our first video, which was on the area of triangles and rectangles. Now we're going to look at parallelograms. So, a parallelogram is a shape incredibly similar to a rectangle. So here we've got some rectangles on our PowerPoint. Now you'll see this shape here, drawn over it, is a parallelogram. You'll see it's like a rectangle that's just been pushed to the side a bit or sat on and squashed. It's moved to the side. So in order to make it into a rectangle, we just trim off this little bit here. You'll see that bit there, we trim it off and it fits perfectly there. It fits perfectly there, making it a rectangle. So a parallelogram is exactly the same as a rectangle. It's just pushed onto the side. Here again, we've got a parallelogram. We're going to slice off this bit here and it will fit perfectly here. And there is our rectangle. So a parallelogram is like a rectangle that's been pushed over. So we can use the same method for working out the area. So here's a parallelogram. We are going to do the height multiplied by the length. That's how we work out our area. Length multiplied by height. Now height is not the measurement along here. It's the measurement directly up. It's the measurement from here up to here. That's how we get our height. So there's the formula. A equals L times H. And again, we're using our perpendicular height. So let's look at an example. Here we have a parallelogram that has a height of 3 meters. I've measured it from here to here. There goes a height of 3 meters and a length of 7 meters. So now we've measured our perpendicular height. We can move that measurement to here. And again, we're going to be working out our rectangle here. We're going to be chopping off this bit and putting it there. So let's have a look at how we'll work out the area of this. We do length multiplied by height, which means our area equals 7. Our length along here, 7 meters, multiplied by 3. 3 meters is our height. So our area is 21 meters squared. 7 multiplied by 3 is 21. And then we're measuring in meters. So we have our meter sign, but it's meters squared because it's how many squares fit inside this shape. So now we're going to watch another MathsPad video with some more examples and some questions for you guys to try them yourselves. So give that a go now.
In this video we're looking at the area of a parallelogram. A parallelogram is a shape with two sets of parallel sides. So these two are parallel and these two are parallel. So there's two sets of parallel sides, which means that two sides are the same. So this side, the top and the bottom, are the same length, and these two diagonal height ones, they're also the same length. So that's what a parallelogram is. When we need to find the area of a parallelogram, it's exactly the same as a rectangle. It's the base times the perpendicular height. The base times the height. And that's the area of a parallelogram. So in this case, the base here is 12, and the perpendicular height, not the slanted height, the straight up vertical height, 12 times 8. The reason why actually is because you could take this bit of the shape, slide it across, so this bit could slide across and fit into here, and you'd actually end up with a rectangle. If you cut this bit off, moved it over here, it is exactly the same as a rectangle. So that's why the area of a parallelogram is the same as the area of a rectangle. It's the base times the perpendicular height, and 12 times 8. 12 times 8 is 96. So it's 96 meters squared. 96 meters squared in this case. Okay, let's look at these two. So the area of a parallelogram, remember, is the base times the perpendicular height. So here we've got a base of 5 and a perpendicular height of 7. So this one's 5 times 7, and that's 35 centimeters squared. We measure area in squares, so in this case centimeter squares. this one, the base, well, we haven't been given the base, but we've been given this length at the top, and because it's a parallelogram, the base is also 8, and then this side would also be 6, but that's not relevant to this question. So the base is 8, and the perpendicular height is this one, 4, not the diagonal height, the perpendicular height. 8 times 4, and that's 32 centimeters squared. Okay, so pause the video and try these two. Okay, so the area of a parallelogram is the base times the perpendicular height. So here we've got 8 as the base, the height is 10, so the area is 80 centimeters squared. Here the base is 9 because it's the same as the one at the top. The parallel lengths are the same. So 9 times the height, which is 6. And 9 times 6 is 54 centimeters squared.
Okay, so now we've done parallelograms, let's look at trapeziums. So these are a little bit more challenging because there's just a few more steps to remember, but it's the same way. You still use a formula. There are just a few more steps to this formula. So let's have a look at it now. So here is our trapezium. This is a trapezium, and we can see we've got marked on here, we've got A, we've got B, and we've got H. So let's have a look at that formula. So to work out the area, you add together A and B, our two parallel sides. You'll notice that these two sides are going in the same direction. These arrows are pointing the same way. This line up here is not going in the same direction as this line here. These two, however, are. They are parallel. So these are the two sides we add together. So we take our two parallel sides, A and B, add them together and half them. And once we have that, we multiply it by the height, the perpendicular height running up here. So A and B are the parallel sides. H is the perpendicular height. And we would use BIDMAS on this, so we would add A and B together first because they're in our brackets. Brackets first. Then we'd move on to our division and our multiplication. So A plus B, work out what that is, and then half it and multiply it by the height. So let's have a look at that with an example with some measurements on. So here is our trapezium. So to work out the area, we need to do A plus B, half it, and multiply it by the height. So let's put some measurements on there. So A is going to be 4 centimeters, B is going to be 6 centimeters, and H is going to be 5 centimeters. So let's start working through this formula using BIDMAS, doing our brackets first. So area equals 4, which is A, plus 6, halved, and multiplied by 5, our height. So area equals 10, because 4 add 6 is 10. Then we're going to half that and multiply it by 5. Half of 10 is 5, and then we multiply it by the height, which is 5, which gives us an area of 25 centimeters squared. Centimeters because all of our measurements are in centimeters, and squared because it's how many centimeter squares fit inside this shape. So again, we're going to check out a MathsPad video with some more examples and some questions for you guys to try yourselves.
In this video, we're going to look at the area of a trapezium. A trapezium is a shape with two parallel sides. So this side here and this side here run in the same direction. They're parallel. And so what this shape's a bit like, it's a bit like a rectangle. You can imagine in this example, if you cut this bit of the shape off, flipped it round, so this bit of the shape, flipped it round, you could put it up here and make a rectangle. So it's a bit like a rectangle. And the way we find the area of a trapezium is by doing the average of the two parallel sides. So half the sum of the parallel sides. So what we do is if we've got 8 and 10, the two parallel sides, we'll get 8 and 10 and half it. So that's the average, the mean average of the two parallel sides, and then you times it by the perpendicular height. So like a rectangle was the base times the height, here we need to do the average of the two parallel sides and then times it by the height. So 8 plus 10 is 18, and half of 18 is 9. So in this example, we'll do 9 times 6. And 9 times 6, that's 54 centimeters squared. Remember, we measure area in squares. So we could say if this side was A, this side was B, and we call this the H, the formula is A plus B over 2 times the H. So this is the area of a trapezium. A plus B over 2 times the H. The two parallel sides, the average of them, add them up and half them, and then times it by the perpendicular height. Okay, so we're going to look at these examples. So remember our formula, A plus B over 2 times the height, the perpendicular height. So this example here, the two parallel sides, that's this one and this one. So A and B are these two numbers. Perpendicular height is 4. This is the slanted height. We don't want that. We're not using that in the question. So A plus B, that's 5 and 11. It doesn't matter which way around you put them. Over 2 times the height, which is 4. Now 5 plus 11, that's 16. So 16 over 2 times 4. Half of 16, that's 8. So 8 times 4, and 8 times 4 is 32. We measure area in squares, so 32 centimeters squared. So we look at this one over here now. A and B, the two parallel sides. That's these two. And this one's the H, the height. So it's 6 plus 14 over 2 times 13. 6 plus 14 is 20. Half of 20 is 10. So it's 10 times 13. And that is 130. In this case, meters squared. And finally here, the shape's kind of twisted around. The two parallel sides are these two, the two running in the same direction. So we'll call those A and B, and we'll call this one H. So it's 6 plus 4 over 2 times 6. 6 plus 4 is 10. Half of 10 is 5, so it's 5 times 6, which is 30 centimeters squared. Okay, pause the video and try these questions. I'll go through the answers after. Okay, so the first one, we should have 9 plus 13 over 2 times 7. 9 plus 13 is 22. Half of that is 11. So 11 times 7, that's 77. In this case, it's centimeters squared. Here we've got 9 plus 5 over 2 times 6. 9 plus 5 is 14. Half of that is 7. So 7 times 6, and that's 42 centimeters squared. And here, the perpendicular height, this one's the perpendicular height. These two are A and B. The 13's there to mislead us, don't use it. We've got 5 plus 15 over 2 times 12. 5 and 15, that's 20, half of that is 10. So it's 10 times 12, which is 120 meters squared. 120 meters squared.
Right then, so now that we've done those, again, if you've got any questions, you can ask us via Slack. You can go back and watch the videos again if you feel like there's something you've missed or you just want to go over it again. Watch the videos a couple of times. The more you practice, the more those formulas are going to stick in your head and the more you're going to be able to do these calculations.